Hello, today we're going to talk about reaction rates, which is basically how fast does a reaction go, and we're going to use collision theory to explain the changes that we see in reaction rates. All right, so collision theory has three basic components. The molecules must collide if they're going to react. All right, so this one seems relatively straightforward, but sometimes students forget it because it's so basic. So they must collide. The second one is that when they collide, they have to have enough energy to make the reaction happen. So if they just like lightly bump into each other, that's not going to be quite enough to make a reaction happen in most cases. All right, and then the last thing is that, the third one, is that they have to collide with the right orientation. So orientation might be a new word for some of you. That is the word that we use to say that they collide. So you can see here and here, they collide in such a way that the atoms that need to make bonds are lined up. Whereas here, these two atoms could make bonds, but this atom and this atom wouldn't be able to. So this would be an example of an incorrect or a wrong orientation. All right. And when we are talking about energy, basically, we're talking about temperature. So if you remember, kinetic energy is directly proportional to the temperature of your system. So as we increase the temperature, two things happen. Because the molecules are moving faster, they collide with more energy. And because they're moving faster, they collide more often. So increasing the temperature will cause more collisions and collisions with higher energy. And the reason we need a certain amount of energy is because of something called activation energy. So our reactants have a particular potential energy. So this is our y-axis here is energy. And our products have a particular potential energy. Okay? But when we go from reactants to products, energy needs to go in order to break the bonds that we have currently and form new bonds. Okay? So that change from the potential energy of the reactants to the potential energy of this state up here, which we call the transition state, that is the activation energy. And the bigger that hill is, the slower the reaction is going to be, or the harder it's going to be for products to be able to be formed. Okay, so those are our basic principles, and we'll take a look at them in more detail in class.